This is lesson 3.1, Functions and Relations. In this lesson, you will learn how to identify if a relation is a function or not a function. There is some vocabulary that we need to be familiar with while studying functions. And the first vocabulary word is the word relation. All a relation is a set of ordered pairs. It can be in a lot of different formats, which you'll learn in just a little bit. It can be shown as a graph, a table, a mapping. So we'll look at those various ways that relations are given to us in mathematics. Another important vocabulary word is the word input. It is a value that is transformed by a process and becomes an output. So let's say we have the equation x plus 3. If we put in 2, so let's say our input is 2, okay, then our output will be 5. So whatever your output will be strongly affected by your input. So the input is your x value of your function. The output is a result after an input has been evaluated in a function. Okay, how about the word function? A function is a relation in which every element of the set has exactly one unique output for every input. And we'll get more into detail with that in just a few minutes. And then the domain is the x value of the function, and the range is the y value of the function. Just another word for x and y. All right, so relations can be represented as sets of ordered pairs, a graph, a table, a mapping, or an equation. So think about the word relations as something that is related to one another or has a relationship. To determine if a set of ordered pairs or mapping is a function, each x value has only one unique output. So let's go ahead and take a look at some different types of relations here. But first, let's just talk about a graphical relation. And when we are studying graphs, there is a very quick way to decide if a graph is a function, and that is called the vertical line test. So we can use the vertical line test to help us decide if a graphical display is a function. So what you do is you draw a vertical line anywhere you would like on the function. And if it only intersects the graph in one spot, then it's considered to be a function. However, if your vertical line intersects in more than one spot on your graph, well, let's try that. Not the best vertical line. We'll go with the one that's on here already drawn. That definitely crosses your graph in two locations here. So that would be not a function. And this previous one is a function. So you can draw it anywhere you like. If you see there is a location that would cross twice, then you do want to draw in that location on the graph. Okay. Okay, so let's look at some different types of relations here. So we're going to look at some t-tables first. So what we want to do is we want to look at the x values, and we want to see remember, these are our inputs. What we want to see is if there are any repeated x values. Well, all of these x's are unique. So because we have no repeated x values, we have a function. So you want to concentrate on your x values, and sometimes you have to look at the y values, but we'll talk about that in a minute. All right, let's look at this table. As we go down the x column, we see we have repeated inputs of 1. Okay, so let's take a look at their outputs. So if you put in a value of 1 and you get out 3, and you put in a value of 1 and you get out a 5, those are different outputs. Okay, you can't have a different output for your input. So this is not a function. The scenario I like to think about it is if you are purchasing, let's say, a gallon of milk at the grocery store, and you go through the line with your milk, okay, and your milk rings up for $2.59. And then your friend is behind you, and they too purchased a gallon of milk, and they ring up the same type of milk, same size of milk, but their milk rings up at $3. You and your friend would look at each other and think, that machine is not functioning because we have the same products, but they're ringing up with different outputs or values. So you would say that something's not functioning right here. And that's the same idea. When you put an input into your function, you should get the same output every time if it is a function. You should not get a different output when you put in the same input. Then it becomes something that's not a function. So let's look at this horizontal t-table, and we look at the x values, and notice we have all 5s for our x values. So we definitely have repeated inputs. So right away we know this is not a function. Next, example 4, 6, 8, 10. All unique inputs. Now, I realize that all our y's are the same, but that is okay. You can have the same output, you just cannot have the same input. So this is a function. Okay, so we're going to look at the inputs here, which is the first value. Do you see any repeated x values that are the same? No. This is a function. Here's something that sometimes gets thrown at you. Sometimes you'll see where an ordered pair gets repeated. So for instance, you might have another 2, 5 in the ordered pair list. Well, at first you might say, ooh, I see 2 2s, but sometimes you do have to take a look and see what the output is. Well, the output is the same for both of these. So that still creates a function because it's just repeating one that you already had. So don't get caught up on that. Okay, next we look at down the x values, and we see we have repeated 2. This output is a 7. This output is a 5. Those are different, so that is not a function. Okay, let's look at what we call a mapping. So what this is really just relating 0 to 1 wherever the arrow points to. So 0 points to 1, 1 points to 3, 2 points to 5, and 3 points to 7. So those are your values if I put them in a t-table. And we have no repeated x's, so this is a function. If you put this mapping in a t-table, notice that 4 points to 1, 6 points to 1, 8 points to 1, and 10 points to 1. We still have all unique x's, so this is a function. Okay, let's go ahead and look at some equations. You're going to need to be able to decide if an equation is a function. And what you want to kind of concentrate on here is locating the x variable, typically. So this is actually here a linear equation. You haven't really studied that yet, but take a look at the exponent on the x. It's really an understood 1. And so if you have an equation where you have an x, then you are going to have a function, except for one exception we'll talk about in just a minute. This can be represented other ways, like it could just be y equals 2x, or it could be y equals x plus 5, or it could be y equals x. Sometimes you don't have a constant. Sometimes you don't have a coefficient next to the x. But notice in all of these, it's just x has an exponent of 1 and y also has an exponent of 1. Okay, let's go down. If we look at this equation, y has an exponent of 1, but the x has an exponent of 2. Okay, so this 2 will create a function because that graph looks like a U shape. It probably wasn't the best example. It actually kind of works its way out. There you go, like that. So if we did a vertical line test on that, it would only cross it once. So when we have an exponent of a 2, that is a function. All right, this one, x has an exponent of 3, y has an exponent of 1. All right, this is what we call a cubic function, and it makes kind of like an S curve. So if you drew a vertical line through this, then you would see it would only hit it once. So if it has an exponent of 3 for the x, it is a function. Okay. Now what's different about this one here is that x has an exponent of 1, but the y has an exponent of 2. If the y has an exponent of 2, this is going to make a sideways U shape like this. And if you did a vertical line test through that, it would hit it twice. So this is not a function. Y equals 1 is actually a horizontal line. So we'll go ahead and draw this because you're going to have to know this. And a horizontal line would pass the vertical line test because we drew a vertical line and it only crossed it once. So this, anytime you have y equals a number, it's going to be a function. Notice there's no x in this one. It's just y equals some number. It can be any number you want. But that would make a horizontal line, and that is a function. Notice most everything we've talked about so far has been a function. All right, and the last one, x equals 3. Okay, this is another special case. This makes a vertical line. Well, if we drew a vertical line test through our vertical line, it would hit it continuously or infinitely. So therefore, it would not be a function. So anytime you have x equals some number, notice just an exponent of 1, no other variables involved, then you will not have a function. So it could be x equals 25 or x equals 100, but anytime you have that situation, it will create a vertical line, and it is not a function. So there's only 2 here that were not functions. Keep that in mind. A lot of equations are functions. There's not that many cases that are not a function. So it's probably easiest to concentrate on understanding what is not a function. Okay, let's go ahead and look at this example. If we draw a vertical line through it, it only hits it in one location, so that would be a function. We'll draw a line through here. Again, you could draw it here, you could draw it right there, but you do want to just make a vertical line. You only need one. It hits it in 2 locations, so that is not a function. That is actually a graph, an equation that starts with y squared equals x plus something. I don't know the exact equation off the top of my head, but that's a y squared equals equation. All right, this one, let's look at this mapping here. If I were to make a t-table of the values, we would have 1, 1, 1, 3. Notice there's 2 arrows coming out of the 1, 2, 5, and 2, 7. Okay, So we have repeated 2's with different outputs, repeated 1's with different outputs. This is not a function. So in a mapping, whenever you have more than one arrow coming out of a number, it will not create a function because that input ends up getting repeated. Let's look at one last table. Look at the x values. We have repeated 4's with different outputs. That is not a function. Okay, that concludes the lesson on functions, not a function.